Hello and welcome back to part 2 of episode 7 of the Build Insite Podcast. This is the final episode of the chat with Ben Walsham of ARKATA and Jessica Allen from Climasure. Join us as we wrap up the conversation of their mission, transforming our homes into higher performing and energy efficient homes.
Yeah, ventilate above your cavity.
Yeah.
Allow the moisture and condensation to drain away and dry out as well. And that's another, actually coming back to sort of drying capacity, and, you know, we talk about it a lot, is around colours. And in the DTS requirements, so deemed to satisfy elemental provisions for the housing provisions and the energy efficiency, they've actually now introduced colour restrictions. So, you know, you can't have a roof in Climate Zone 5 darker than 0.64, I think, solar absorbance, which is a colour-bond wallaby, I believe. So your colour-bond monuments in elemental provisions, you can't do. So,
which is going to break a lot of hearts.
Yeah, so if you wanted to build a roof with a monument roof, you have to go and do NatHERS. You have to go and do a star rating. So that's essentially what they've done, is like they've sort of pathwayed the energy efficiency a little bit more. So if you want to build a roof that's darker than that, you have to do NatHERS, and then you have to meet 7 stars, right? So they've made the code a little bit more robust in that way to sort of bring everything up to the 7-star level. And so, but then building science perspective is that darker roofs actually increase your ventilation in the roof. You know, because you're speeding up. Yeah, because you're speeding up that ventilation through the roof cavity. And so it can actually have a benefit beyond just your energy efficiency as well. And so this is where these things start to overlap and really get intertwined.
But that's particularly if you use the above sheathing ventilation system.
Yes.
Yeah, so that's where they go hand in hand, the colours and just using building science to remove heat and moisture.
Yeah.
But yeah, we do have an article in progress on anti-colon blankets, so watch this space.
When that's live, where could people find that?
Oh, we'll post it.
Probably both websites.
Yep.
LinkedIn, websites, social media. It'll probably be everywhere.
Yep, awesome. We'll pop a link to Climasure and ARKATA's socials websites. We'll pop those in the show notes so that everyone can click on those and find it straight away.
Yeah,
Great.
Awesome.
All right. I'm going to throw this question over to Jess. Can we just touch on some of the passive house principles and how they can be implemented, please?
Sure. So passive house is a German framework. It is sort of most rigorous framework for energy performance in the world, and it relies on 5 main principles. They are high performance windows, high levels of insulation, airtightness, thermal bridge free construction, and mechanical heat recovery ventilation. So all of those 5 things are covered off in the modelling. It's modelled the same way as a star rating is modelled, but on a much more detailed level. Every element of the home is essentially modelled, and heating and cooling demands must be under a set maximum. So in terms of implementing those 5 principles, probably the main thing I would say is that you can build an energy efficient home without getting a certified passive house. And there may be some people in the passive house industry who disagree with that, because there is an inherent risk in doing something in a halfway, particularly when it comes to correct ventilation and thermal bridging. If you don't fully understand or execute those things properly, then you can end up with mould and, unhealthy indoor air quality. So it's really a matter of getting the right people on your team who understand what those 5 principles are and what the potential consequences are of getting it wrong, and how to measure it as well. So implementing high performance windows is just a matter of paying for the best windows that you can afford in your budget. Implementing airtightness, you will need a consultant on board for that. That person will help you decide on an airtightness target. They will help you delineate your air barrier, help you detail for air tightness.
What are you aiming for passive house? What's the air tightness measurement that we're aiming for?
A passive house air tightness test needs to achieve under 0.6 air changes. So to put that into some context, the Australian average at the moment for a house is about 7 or 8 air changes per hour. A few years ago, the Australian average was 15 air changes, 15.4 air changes per hour. So we are, improving over the years. But the problem with an air tightness measure in terms of NatHERS is that it's not modelled in a NatHERS rating currently. You can model an air changes per hour figure in non-regulation mode, which can indicate to you the difference that an air tightness score makes on energy efficiency of a house. But at the moment, there's no official way of doing that. So if NatHERS modelling assumes, let's just say it assumes approximately 10 air changes per hour, but your house is built to 5 air changes per hour, it's actually a lot more energy efficient than it's been modelled at.
Yep.
So all the gaps and cracks in the building fabric that are leaking air that you don't want to, like underneath skirting boards, around windows and doors, through exhaust fans, through electrical penetrations, plumbing penetrations, all these different places, gaps in floorboards, places that air can leak out that you don't want it to.
Yep.
That can deplete the performance of your house. So also, conversely, if you model a house at 5 air changes and it's actually built at 10, then it's not as energy efficient as you thought it was going to be.
Yep.
So
just to backtrack quickly if you don't know what an air change per hour is.
Yeah. Air changes per hour is how much air is leaked out of the building per square metre of volume of the house at 50 pascals. So the test is done under a pressure of negative pressure of 50 pascals. We use a fan that was installed in an external door, and the fan is turned on, air is extracted, and the house is depressurised to 50 pascals.
Yep.
The amount of air that is required to get that house to 50 pascals is measured, and then that number is divided by the volume of the house.
Yep. We might actually, I might link that in the show notes below, as well as a little YouTube video that Jess and myself did on one of our current projects as a bit of an introduction.
To speak to everyone that lives in a really leaky house. When you put your heater on and then you're nice and warm for a couple of hours, and you're like, oh, I'm really hot. All right, I'm just going to turn the heater off. And then within 10 minutes, your house is already cold again. That is your air tightness or lack of air tightness.
Yep.
And, coming back to my personal experience, the last house, we would have the aircon on, during summer, and we would be nice and cool, turn it off, and, within half an hour, we were back to being just sweltering.
Yeah, all the conditioned air is just leaked straight out.
The conditioned air doesn't even stay in the house, just actually finding its way through. That is your natural air change rate of your house. And the quicker that is, the more leaks your house has, the more money just slips through those cracks. You can visualize it, right? Money, cracks.
Yep.
And so, coming back to that, it's like, that's your air change rate. And so it has a really profound impact on your comfort and your health as well. So,
and people in Adelaide, they can reach out to you, Jess, to do blower door testing.
Mm-hmm.
Yep.
Yes. Yep.
Yep.
Through the website. You can book a blower door test on our website if you like, or just give me a ring. The number's on the website.
Awesome.
Yeah.
What stages would you recommend people do it at? Again, probably depending on the type of project.
Yeah, well, same as Ben, it's a process change, because if you want to achieve a certain level of air tightness, then it needs to be planned into the design. So at concept stage, I would get someone like me involved to help you work out, where your air barrier is going to be, because that document is it's called a red pen. We would do what's called a red pen test, where we draw a line around the air barrier, and that's a really crucial communication document for the people who are building the house, because they need to know, one, that an air tightness test is even being done, and two, that there is a target, and that they need to be much more aware when they cut a hole in the plasterboard or whatever the air barrier is going to be. It's usually the plasterboard in a standard home. If they put a PowerPoint in the wrong place and move it, they can't just leave that hole there, cover it up. If they're only moving it an inch or something, you still need to patch that hole.
It's going to be really crucial for builders if they're having a crack at it to make sure that they're educating all their trades as well.
Yeah, it's a really good document.
The electrician can't just come and cut a hole in the external membrane,
That's
poke
right.
a cable through it and leave it.
That's right. And underskirting boards is a big one because your skirtings run the whole perimeter of your house, and if there's a leak that comes underneath your bottom plate and through the skirting,
Yep.
that's not meant to be there, then it adds up to a large leak. Power points are another one that add up.
Yep.
Architraves around windows, they all just add up.
Yeah.
Very quickly.
Yeah. So I guess come back to it's a collaboration through the construction as well. It's not just in the early stages getting the design right.
Yeah.
It's a collaboration of the entire on-site team to make sure that everybody's achieving the best results as well, making sure that nothing gets left out.
Yeah, and if you can quantify the amount of air leakage that you do have, you can then, that informs your ventilation strategy.
Yep.
So if you accidentally, if your builders, especially in apartments and things like that, townhouses where they've got partition walls and they are, just because of the way they're built, they're naturally going to be more airtight. Or if you've got a builder who is quite diligent and they build the house to a level of airtightness that's quite good, and then you're not aware of that, then you can end up with, if you're not ventilating properly, if it's really hot, if it's really cold, your windows are all closed up, then, you can end up with poor indoor air quality without realising it. You can end up with high humidity without realising it.
Yep.
And so having that air change number helps to inform how you manage your indoor air quality and your condensation risk with the humidity levels in the house.
So it's definitely clear that airtightness is a crucial element of it. What about some of the other elements of passive house? How do people implement those?
Okay. So moving on to the other pillars. So thermal bridging is where there's a thermal bridge is the heat conduction or temperature conduction through a building element. So we all know that metal conducts more heat. So aluminium windows, steel beams, steel columns, all of those sorts of elements in a building are where your highest condensation risk is. So more than airtightness, thermal bridging cold spots equals mold spots. Cold spots, thermal bridges is the leading cause of condensation and mold in any building. So where you can, design steel out of a building. And if you can't design steel out of a building, then just make sure it is insulated on the outside of the steel member so that you can stop that steel from getting cold.
Yep.
With windows, if you can, thermally broken frames.
What would be the risk of if people got that the wrong way around and they had the steel on the outside and insulation on the inside? Is that just a recipe for a really big condensation problem?
Yeah, it's too late at that point.
Yeah, if the steel gets cold and you get any sort of warm, humid air on that member, then on that steel, then your risk of condensation increases.
Yep. Yep.
Yeah, you want to stop it from coming into the building,
into
essentially.
The fabric. You want to keep that outside. And that happens inside the building fabric where you can't see it as well. So the interstitial places inside the wall and inside the roof, that's where most of the issues happen. It's not where you can see it. Often it's inside the building fabric. And then by the time you figure that out, it's usually a big problem.
Yep. What are some people's ventilation options?
Opening up windows is a good one.
Yep.
Airtight people, as explained earlier, people are afraid of airtightness, but having an airtight home does not stop you from opening up doors and windows.
Yeah. I guess that's actually probably one thing that when I'm trying to explain to people about these principles as well, is everyone goes, "Oh, what does that mean? Like I can't open my doors and windows?"
Yeah, that's why we need to change it to leak free because then I can have my windows open when I choose to.
Yep.
Yeah, it's ultimately about being able to control when you ventilate your home instead of having ventilation just happening when you don't want it to, gaps and cracks, dust, bugs, rodents, all of those things. You don't want that in your house. So it's about controlling it, keeping the outside out and the inside in at your will.
Do you need to get a little bit strategic about it as well, I suppose? Like if it's really, really hot, open up first thing in the morning, purge the house when it's nice and cool and close up before it's too hot and vice versa. If it's in the middle of winter, you want to, if it's nice and warm during the day, obviously close up at a strategic time before you let all that cold air back in at the night.
That's right,
Yeah, night purging is a thing. So open up your windows at night when the temperature drops, let all the hot air that's built up in your house during the day, out overnight.
Yep.
What was I going to say?
Mechanical options?
Cut this. I was going to say mechanical options, but I was going to say something else as well. It might come back to me, but I'll go to mechanical.
Yeah, I guess one of the biggest things is you don't need to reinvent it every project as well. Like you can, once you've done it 1 or 2 or 3 or 4 times, like you're going to be like, okay, I get this. I can roll this out every project.
Yep.
You got set inclusions, set standards, dedicated exhaust fan above your shower, actually taking it out at the pace of the highest humidity creation, high quality range hoods, things like this. And I have to sort of bring it into the conversation, but Jess recently got an uHoo air quality monitor.
That's what I was going to say.
And the data she gets from this thing is amazing, right? So she put a LinkedIn post out the other day, so you can go on her profile and see this sort of dashboard of information that you get. And honestly, if you're a builder out there, you should just honestly have this as part of your handover package. Just buy your client one. I think they're like $500 as a nice little present to hand over a high quality home.
Besides having a funny name, I have no idea what an uHoo air monitor is. Can we maybe just have
branding needs an adjustment, but no.
A bit more elaboration on what that is?
So an uHoo monitor it's about this big and it just sits on your bench. And
if you're not physically watching this, Jess's hands were about 200 mil apart.
Oh yeah, so yeah, thank
200
you,
mil.
Yeah, so it's just a little desktop thing that just sits there minding its own business and just measures, I think about 8 or 10 different things in the air. So it measures, first of all, temperature and relative humidity, and I believe that those 2 things are fairly accurate. Because I know that measuring instruments have to be, calibrated and various things. So this is a useful instrument, but I think some of the things that it does monitor couldn't be used for specific scientific purposes. It's more of an information for a homeowner.
Sure. Yep.
But the temperature and humidity, I'm told, are very accurate. So it measures temperature, humidity, it measures particulate matter in the air, it measures carbon dioxide, carbon monoxide, it measures VOCs, and a few other things. But yeah, so it just gives you a really good indication of your air quality.
Yep.
And the other day we had a lot of rain, and my house, just to give you an idea, probably a lot of rubbish brick veneer houses sit at about the same level, but my house sits without my heating on at about 14 degrees at the moment. It can be 11 degrees outside and 14 degrees inside. That's pretty standard. And it sits at about 55 to 60% relative humidity. That's on a regular day. But the other day we had a lot of rain, and I looked at my dashboard and my relative humidity had shot up to 70% purely because of the rain. That shocked me. It just because my house isn't airtight, the moisture in the air had just leaked through the fabric.
And the house was closed.
And the house was closed. I wasn't home. Nobody was home. And yeah, which means if you know how dew point works, if the relative humidity goes up, the dew point also increases, which means that I had a higher condensation risk just because it had rained outside and the humidity was seeping into my house. So it meant that the surface temperature that needed to happen for dew to happen increased, which means the risk is increased. So, yeah, it's fascinating information. I love data, blow door testing, numbers, all of that stuff. I get a lot of satisfaction out of understanding it all. So, yeah, I recommend getting a monitor that at least you don't have to spend $500. You can get cheaper ones that just measure temperature and relative humidity.
There's lots out there, definitely, yeah.
Can people hire you to come and do a test with your machine?
You probably need to leave it in a house for a week or so to get an understanding of what it's doing. And depending on the season and the climate, it's going to be different for every house and the fabric. But yeah, I would actually love to take my monitor into different. There's one in the display home in Mount Barker, the certified display home. And the data that comes out of that monitor compared to the data that comes out of mine is completely different. Both, the display home is unoccupied, so there's no people living in it, not showering, cooking and things like that. So the results are different purely based on the fact that it's not occupied. But it sits between a passive house, certified passive house, is designed to sit between 20 and 25 degrees every day of the year and 40 and 60% relative humidity. And the passive house successfully does that most of the time. It's a bit below 20 degrees at the moment because there's nobody living in it. And the body heat is taken into account when modelling a passive house.
And this is what you're talking about is with no conditioning, like no heating, no cooling.
No heating and cooling.
That's just its natural state.
Its natural state.
Yep.
Yeah, it does what it's supposed to do. And then I compare it to my freezing cold house with humidity that's too high and, impacted directly by a large amount of rain outside. That's not, my house is not keeping outside out and inside in.
It's really incredible. I mean, I think the World Health Organization say that anything below is 18 degrees, someone can maybe correct me if I'm wrong here, but is unhealthy for you.
That was in the news last year, wasn't it?
Yeah, and so they've sort of
homes.
they've brought out this number that if your house sits below this for most of the year, then it's actually really bad for you and for your health. And so you're saying your house sits at about 13, 14 degrees during the winter. My house is basically the same. It's about 15 degrees without the heater on. So it's like, okay, 2 out of 3 houses, you might have a different experience, but it's a prevalent... I wonder
how many other people just got chills down their spine when you mentioned that.
It's a prevalent thing, right? And that's what we're here to do.
Information is power, really. Yeah. And these monitors are an incredible resource.
Yep. All right, let's circle back. We didn't quite get to mechanical ventilation. Let's just circle back there quickly before we go too far off topic.
Yep. So mechanical heat recovery ventilation is one of the passive house pillars, and that is a mechanical system. It can be a centralised system, which is ducted, similar to the way an air conditioning system is ducted. The mechanical heat recovery systems, though, are inside the thermal envelope. So if you've got a normal air conditioning system, the ducting sits above the insulation in the roof cavity and penetrates through the insulation to get through to condition the house. And heat recovery ventilation system is kept within a services cavity, which is below the insulation. So it's completely insulated by the building envelope.
Yep.
And what that does is extracts the humid air from the wet areas and supplies clean filtered air from outside. And there's also a system inside where heat from inside the house is transferred to the incoming air, so that your air from out, even if it's 11 degrees outside, you're recovering some of the heat from inside the house and transferring it to that outdoor air. So the air that's being delivered into the home is more or less the temperature that's already inside the home.
So the central unit is a heat exchanger.
It's a heat exchanger.
Yep.
So and similar in summer, where the temperature inside is being transferred to the incoming air, so that you're getting fresh air from outside, but you're not getting the really cold or really hot temperatures from outside coming directly in. It's actually being moderated. It's not a heating and cooling system, though. And in Australia, even in a certified passive house, you often need a small air conditioning system because there are overheating issues in Australia, because it's a German system. It wasn't designed for, initially designed for an Australian climate. So sometimes there is an overheating issue in Australia.
I feel it's going to be interesting over the next couple of years. The more that this comes to light, is hopefully our air conditioning systems are going to slightly get smaller. Because I know talking with our tech at the moment, with I guess trying to increase our building standard, trying to build better in general, we're still a little bit nervous, I suppose, on having undersized air conditioning units. So they're still in based on, like, I think some of the quotes that they send through has got the data that they've used, how they've actually sized it up. And it's based on like R3 insulation bats in the roof, R1.5 in the walls, and a certain like air leakage rate. And it's not even close to what we're actually going to be building on site.
Yeah.
So I guess maybe there's in times to come, maybe their software will be updated a bit.
Whole of Home can actually help you size air conditioners.
Yep. Okay.
Based on the star rating, the building performance, the building fabric, you can actually start to get that data out. But coming back to these heat recovery ventilation units, one of the things as well, bringing it back to the health, because I love that.
Yep.
There's filters on heat recovery ventilation systems that need to be changed every so often. You might be able to speak
once a year or so.
Once a year. Yeah. I've seen a couple, and they're usually black when they come out. So not only are they...
Well, that means they're working.
Yeah, not only are they keeping your house comfortable and replacing the air, they're actually getting rid of all the dust and allergens and toxic pollution that leaks into our homes normally. And so again, coming back to that indoor air quality, these things actually do just so much more, and it's unmeasurable. It's intangible, right? The health aspects of it. And so, yeah, they're a super fascinating piece of technology that do a lot for a house. So,
One of the things that my uHoo monitor does show as well is particulate matter in the air. And at the Passive House conference recently, we had a talk where one of the speakers did an experiment where he took his uHoo monitor around with a certain cooking pan, and he cooked an egg in different houses and watched the particulate matter change. You'd be absolutely amazed. Like when I cook in my house, my particulate matter goes shoof. It absolutely skyrockets into the red zone. And that's what prompted me to get an uHoo, was this guy's talk and showing how the particulate matter spikes, because particulate matter in the air can affect lungs and breathing, and it can affect cardiovascular health as well.
Are you talking as in like chemicals that come out of the pan?
I don't know
just a combination
exactly what
I
it
think.
is. And I've also got a gas cooker.
Right.
So I'm cooking with gas.
Yep.
Carbon dioxide issue is an issue in my house, apparently. I've got a gas heater as well. And my carbon dioxide can get up into that sort of amber zone regularly.
Yep.
But yeah, this just cooking. Every time I turn the stove on, the particulate matter shoots up into the red zone, and it's the mechanical heat recovery ventilation system is like, my exhaust fan is not powerful enough to get rid of that particulate matter, but the mechanical heat recovery ventilation systems, they're continuous and they just keep everything under control.
Yep. They run 24/7.
They run
don't
24
stop.
hours a day.
Yep.
And so you can get the centralised systems, which is the ducted system, and you can also get decentralised systems, which come in either a single point system for a classroom. They can be used in classrooms, or you can get in a house. They come in pairs, and you can either have 1 pair, 2 pairs, 3 pairs, depending on the size of your house. If you build your house and you get a blow-door test done, and oops, we made it too airtight, you can retrofit decentralised pairs of mechanical heat recovery systems where one system will supply air and one will extract air.
Yep, it's a push-pull system.
And then it will switch and turn around the other way. So I think that the sale of those sorts of systems is going to be quite strong in the coming years as people accidentally over-tighten or become more aware of indoor air quality problems.
Yep. I guess I know a few other people that some of the other Build Insite hosts as well, actually they've used quite a few of those on just some retrofits that they've done where it's not possible to get a centralised system in. So just being able to core a hole in, say, for example, like a double brick wall.
Yep.
I guess that's probably the only downside to the decentralised units is they're quite long, whilst they're not huge in diameter, probably only about maybe as round as a football. But you do need I think they're anywhere between 250 to 260 mil deep. So if you've only got like a smallish sort of wall, you may need to build a little box section on the outside to house it.
Yeah, so they can be they do stick out a bit depending on the thickness of your wall. Yeah.
Yep.
But they can be prettied up.
Yeah. Yep. Cool. Any more bits that you want to touch on with Passive House principles before we wrap this up?
Did we go through implementing all of it? Airtightness, mechanical heat recovery, windows, insulation. Installation of insulation is
super crucial.
It's super crucial. And it's something that is covered up with plasterboard and no one ever looks at once it's done. But as I mentioned earlier with roofs, insulation works using the air pockets in the bats. And so if you've got crushed insulation, it's too big for the cavity and you've squashed it in, it's not going to be working.
Yeah, I was going to touch on that as well.
As it should.
A huge misconception with homeowners in particular is just because you've got a gigantic bat, if it's completely squashed, it can't do its job. It needs to be puffed up to be able to trap the air.
Yeah, and putting an R3 bat in a 90 mil wall, it might sound good having R3, but if you've squashed it to fit in a 90 mil stud, it's not going to be working.
Yep.
So you need to increase the size of your studs if you want to increase the size of your insulation bats in your wall. The other thing that is really common is corner junctions in homes are often built with a void, so that don't get insulated. Like internal wall to external wall junctions are often built the same way, and you can't get insulation in those areas.
Yep.
And so the idea of this high levels of insulation isn't just high R value; it's as continuous as possible, because what you're trying to do is increase the cover and decrease the amount of thermal bridging through that insulation.
Yep.
So ideally, you actually have external insulation that is continuous around the entire house, but there's space issues there because you've got a stud, unless you're building out of SIP panels, which is a continuous layer of insulation. If you're using stick frame and insulation bats, just making sure that those bats are flat and not squashed, and there's insulation in every single gap you can possibly fill.
Yep. There is a percentage actually, isn't there? I think is it 5% of gaps reduces by 50%? Is that right? The efficiency of insulation bats? I'll have to check that out, but it's a horrifying number.
Yeah, but heat will take the least path of resistance straight out of your building.
Yep.
And it's the same in the roof cavity with downlights and exhaust fans. Check your insulation, because oftentimes, every time I say this, I get builders going, oh, yeah. It's sort of this resounding acknowledgement that if anyone goes up into the roof space and they're fiddling around with wiring or ducting or whatever, and insulation gets disturbed, downlights get installed and insulation isn't replaced, then there can be gaps left. Like, I've done thermal images of houses where there's entire bats missing out of the ceiling space, and that depletes the performance of the insulation hugely.
Yeah,
hugely. Just one bat. Yeah, and I've had wall bats missing as well. It just happens, and builders think that no one's ever going to know.
Wall bats is a pretty crucial one to get right to start with. At least most ceiling voids are accessible, that if trades pulled an insulation bat out the ceiling, someone can get up there and fix it. That's, I guess, comes back to educating the entire on-site team and that collaboration. Make sure that if you pull it out, explain the reasons behind why it needs to be exactly the way that it was before.
Yeah.
Otherwise, you've just got cold spots everywhere.
And, get a thermal camera and tell the trades that they're going to be checked.
I bought one, actually.
Nice. Yeah, good on you. Because
anyone can go borrow them at the local library as well. Most libraries have them as well.
Yeah.
Which is pretty cool.
Wow, I didn't know that, actually.
Yep.
Yeah. So, just making sure that people know they're going to be held accountable. And that's the same with the airtightness test. There's going to be a test. We're aiming for this result. We're going to be checking your insulation with a thermal camera.
Yep.
Just keeping people on their toes.
Awesome. All right. Any final words?
The new NatHER certificate has a really good checklist on it.
Okay.
So it has checks for the consultant doing the assessment, checks for the certifier as well to help them, checks for the builder, checks for the architect, checks for the homeowner. So it's a pretty comprehensive checklist as well. So it's on the new NCC 2022 7-star certificate. And we were sort of talking about this again last week, that it is much better than the previous certificates, much more holistic, and it's something that a builder could even just take the checklist and put it as part of their own QA processes.
Who provides the checklist?
Well, it's just as part of the certificate. So when you get a NatHER certificate, it is just a part of that. That document. So, and those things are going to be better, because then it's maybe we actually start to build things as per the certificate as well, which is good. So
it's probably not something to tack on the end of this conversation because it's a big conversation, but I will just briefly touch on membrane type. I've had a lot of complaints recently from homeowners, because they are getting much more educated, as you were discussing before, about what they want their builder to do. And I've had a lot of complaints recently about the incorrect membranes being used in Climate Zone 6 in particular. A lot's happening in Mount Barker in particular, where the volume builders are using their branded membranes that are outdated. They can't use them anymore. They don't have the sufficient level of vapor permeability to meet the building code. But due to lack of understanding and a little bit of wanting to use up the stuff they've got, they are installing incorrect membranes into homes. And if homeowners aren't aware of that, then they end up with potential mold problems down the track.
I'm not going to name builders, but going back from my previous experience. So I'm a carpenter by trade. Yep. I started out when I first did my time. I decided that I guess as maybe a lot of young carpenters do, let's just go frame houses.
Yeah.
It'd be great fun. It was terrible. Made no money out of it. But it's actually the responsibility, and I don't know, this is just the one particular volume builder that I worked for. It was our responsibility to supply the wrap.
Yeah, right.
So I guess there's...
Apprentices.
No. So this was me as a subcontract carpenter, but it was still our responsibility. They would supply all the timber, but we would have to supply all the sundry items, and we would have to go and supply the wrap. So of course, if a carpenter that's just out of their trade, they have no idea. They just, what are you used to, or what do you see on houses?
Go to Bunnings and
you go and buy the
first
cheapest
thing.
one possible, don't you?
Yes.
Yeah, that would have been my
easy switch to make.
Yeah, my question for you is, did you look at the plans or the specs and then try and figure out which one it was, or you just went straight to Bunnings?
No,
and
just
was
went
like,
straight for the cheapest one.
We can talk to architects. In fact, we had a lengthy conversation last week with an architect about this, and they were like, we need to specify, because builders are getting it wrong, and we need to be specific.
They are. There is no information.
Are you reading the plans?
Well, yeah.
Do you actually read the spec?
Don't write it in one tiny little box on the first page in such fine print that you can't read it. Because, this is...
It's important.
Please, listeners, we're not doing this anymore. We're not buying the cheapest one. I'm going back probably about 15 years ago now. But,
but there will be people who are doing that now.
At the time.
And I know there are.
The builder doesn't educate the trade. The trade... They're out there wanting to make as much money as they can in the early stages, so they just go and buy the cheapest one and throw it on.
Yeah, so just to give a brief rundown on what this all means, there are 4 categories of vapour permeability. I'll try to keep it simple. In climate zones 4 through to 8, all of those houses now must be built, if you're using a membrane, with a membrane with a level of vapour permeability. So 1 and 2 are vapour barriers, classes 1 and 2. Classes 3 and 4 are vapour permeable membranes. So anywhere in the southern half of Australia has to be built with a vapour permeable membrane if you are using a membrane. Any cold climate zones, so climate zones 6, 7 and 8 have to be specifically a class 4. And that's right. And class 4, climate zones 4 and 5 can be a class 3. I know it's a lot of numbers and it's confusing for anyone who doesn't understand it. I get it. But just know that anywhere in the southern half of the country has to be built using a vapour permeable membrane. Ask your builder about it. Make sure they understand it, that they get the right information, because you could be opening yourselves up to mould risk and legal liability potentially down the track.
Cough, cough. Anticon is a class 2.
It is, but it's also in the roof, and I don't. Yeah, it's a whole.
Just throwing that out there.
Yeah.
And foil-backed membranes with holes in them are vapour permeable because the holes allow vapour through, but they suffer in durability and they also aren't waterproof. So you might be ticking one box but missing out on another box.
And I've seen way too many of them firsthand with existing roofs that you pull off and it's completely disintegrated under the roof.
Decimated because the heat gets to it. Disintegrates it. It wasn't installed properly in the first place. The tape has come undone. The tape doesn't stick.
If it's taped.
It might stick when it's being installed, but once you put the cladding on and wind forces get into that cavity, it's going to be ripped to shreds. There's a high chance. So getting the right membranes, protecting your insulation from wind washing, protecting your frame from water, all of that is going to significantly contribute to the health of the building and the health of the occupants over the long term. So the membrane, although it might not seem important to sort of when you're building your house, who cares about the membrane? It's actually really important.
Yep. All right. I think we might have to get you two back on for another episode in the future, I think, because I feel like we've already just scratched the surface.
Yeah.
You know, Jess and I can probably sit here and talk about this all day. So we love it.
Good. All right. Well, thank you so much for coming on today to the both of you.
No, thank you so much for having us.
It's been an absolute pleasure to have you, and I'm sure our listeners have gained a hell of a lot of information out of what's been discussed.
I hope so.
Thanks, Luke.
Awesome.
Let's cue the disclaimer. It's Anthony here from Build Insite, and I need to let you know that myself and the Build Insite team are in no way, shape or form qualified to give you personal or specific business advice. We strongly encourage you seek out the use of professionals for products or when you are making personal or business decisions. Everything discussed during the Build Insite podcast is our own and the guest opinion and personal experience and is of the general nature only.